All right, so Taiwan, even though you might be looking forward to falling asleep and stuff, I don't really need to spend a lot of time on this first page, because a lot of it is either stuff that we're not going to use or stuff that I already went over. What? I thought you were passing them out. That's all Taiwan's fault. All right, so all I really need you to do on the first page is let's go erase this vertex form formula, because that includes the type of transformation that we're not going to use here in Algebra 1. So I just want you to rewrite it a little bit more simple. This is the way it would look. Just the formula. Yeah. We're not going to use the C that's on your notes. So now, look, okay, what is the big difference between what you see today in vertex form versus what you saw last week in standard form? What would be the big difference? What stands out to you? The parentheses, that's the big one. Okay, now, like this week, I believe your homework is on Khan Academy, and they do some things with factored form, which we've already actually done factored form, and factored form also uses parentheses, but we're not going to really emphasize factored form when it comes to graphing. But just realize, like, factored form is like 2 parentheses. Vertex form is just 1 single parentheses with a square on the outside. So once you see that and you recognize vertex form, instead of identifying A, B, and C like we did last week, we're going to identify A, H, and K. Good news, A does the exact same thing. The only difference is now instead of just being in front of the X, it's also in front of a parentheses. But if it's positive, parabola goes up, negative, parabola goes down, just like it was last week. But what we're replacing is the B and the C with the H and the K, which is probably a good thing, because what did we learn last week that H and K stands for? What does H? Yeah. Very good. H and K are going to be the coordinates of the vertex. So instead of having to find them by using a formula, the vertex, which is arguably the most important point, is going to be given to you for free. Now, the trade-off is, what was the point you were being given for free last week? The y-intercept. Well, that's not going to be the case anymore. If you wanted to find the y-intercept, you would have to do so either algebraically by plugging in a 0 for x, or you can get away with sometimes doing it, finding it graphically. You just kind of stumble across it graphically. But I mean, if it's me and I'm being given the choice, I'd rather have the vertex, because every parabola you have to graph the vertex. You don't necessarily have to graph a y-intercept. The stuff that's here we already went over. When A is positive, this vertex is a minimum because the parabola is facing up. Okay, when A is negative, the vertex is a maximum because the parabola is facing down. We know our axis of symmetry is always going to be at x is equal to h. And the rest of the stuff you can cross out, because that was just the way that I used to teach to come up with the lateral points, the points on the sides. But we kind of simplified the process. So you can scratch off anything below axis of symmetry. You don't have to worry about that. So here we go. Let's start the examples. Notice how all 4 of these are in vertex form. You see the parentheses with the square. So now, instead of identifying A, B, and C on each one of these, I'm going to identify A, H, and K. A, H, K. A, H, K. A, H, K. And then I can go answer my questions. Chair Bear. Come on. All right, so look at the first one. What number is in the A position? 2. Now, before you get too excited and tell me what H is, I want to point something out. If we go back to the first page, this H has something that you've seen before in front of it. You saw some of this in quadratic formula. You've seen this in slope formula. You've seen this in point slope form, which is you have a minus in front of an unknown. What happens if you stick a negative in front of an unknown? What happens if you stick a negative in front of a number? It doesn't always change the negative. It changes the sign. If I stick a negative in front of a positive, it makes it negative. If I stick a negative in front of a number that's already negative, it makes it positive. So I'm telling you that because if you look at the formula for vertex form, what happens is whatever number you think you're seeing for h, you're actually seeing the opposite sign. So like a lot of people will look at this, and this is the most common mistake. They're like, oh yeah, h is 3. No, it's not 3. H is actually -3. The reason why you're seeing a plus there is because the negative from the formula and then the negative from the h. Negative is a plus. No, that's not the case for k, right? Look at all these rules you have to memorize. For k, it's whatever you see is what you get. So k is -4. Xavier, comfy? You got a nice view of Soha and you got your feet kicked up? And do you mind putting your feet down? Appreciate it. Nick, where's the vertex going to be at here then? Instead of having to go through all that trouble finding h and k, I already have it now. Let's give it to me. So, where's the vertex going to be at? You shouldn't have to guess. Yes, Hope. Yeah, -3, -4. We know it's going to be at hk, and there's -3 and -4. Axis of symmetry is going to be the same as it was last week. X equals h. I have h. Now just don't forget the x equals part. The x equals part is what tells you that it's vertical. It's a vertical axis of symmetry. So it's going to be at x equals what? -3. And it's just going to open up or down?
Down. No, up.
It's Taiwan's fault. Yeah, A is positive, just like last week.
No. Yeah. No, I think.
She thinks, therefore she is.
I thought.
All right, let's go with number 2. What's A there?
1.
Not 1.
That's
-1. Good. There's a negative in front of the parentheses. So A is -1. H is?
No,
+2. Don't forget to change the sign for the H. That's the most common mistake. K is 3. K, don't change the sign. Mainly, where's the vertex at? Thanks, maybe. Cassandra, what's the formula for the axis of symmetry? Say it better. Good. Darío, up or down? ¿Qué?
Down.
Very good. It is going down. It is negative. Ruben, do you want to tell me A, H, and K for the next one? Nah. Okay. How about JG? You want to tell me A, H, and K? For number 3? A is 1. Good. -5 is H, that changes sign.
Oh, yeah.
And then K is? Oh, wait, mister, I don't see a K. Nothing's being added or subtracted. So where is the vertex? -5, 0, Oh, for sure not. And x equals -5.
I already did that.
Emilci, up or down, para arriba, para abajo, ¿dónde va el parábola? Yo no sé. Sarah, do you know up or down? Up. A is positive, up. And then, Emma Grace, what's A, H, and K for the last one? Shush.
A is
Yep. No, H, give me H.
Oh, H. Is that -6?
No! Now! You gotta change the sign. It's the most common mistake.
Okay. So positive.
Stupid. I said that.
Taiwan, that's not nice.
Slow channel.
Oh, I literally wasn't there. Oh,
Yes,
you're
you're
there.
I said it. I was trying
Vertex is gonna be at 610. Axis of symmetry is at x equals 6. And it's
Down.
going to open down, diggity down.
So it's the same, like,
Okay.
A is positive.
Yep. For sheezy.
You know, me and Elsie, we were doing math homework at the house, and we got so frustrated because we were trying to like watch a video and everything, and it lied to us. Your video lied.
That's impossible.
It was no, we were trying to do it, and then we put it in, and it was wrong. We did every step exactly how we did it.
I doubt that seriously.
We just.
It's probably Taiwan's fault, but
I believe it.
I was at a barbecue. That's what I was at.
we're eating.
Well, no, if the food was done.
All right, so here we go. Let's just graph here. Well, you might hate graphing, but here graphing is going to be much more user-friendly because since this is in vertex form, the vertex is going to be given to you. That's a lot less work than what we had last week. What's A? What's H? What's K?
-4. I'm just 0.
It is 0. So my axis of symmetry is going to be at x equals at x equals 2, not -2. So I would find 2 on the x-axis, and I would draw a vertical line through it. My vertex needs to fall on there, and it will. It's going to be at 2, 0. But just like last week, how many points do we want to graph?
5.
We want to graph 5. So we need 4 points, and those points would be lateral points. The word lateral means like on the sides. Okay. Now, really, we don't have to find all 4 because we can use the axis of symmetry to just, once we have 2, we can flip them over. So the question is, well, how far away do you want to go on the vertex? So somebody's like, oh, mister, do you always use 1 and 2? Do you always use 1 and 2? Well, yeah, unless for some reason I can, unless for some reason it's already being used up, or another thing I brought up, which is about half of these problems, like some of these, like this one, you see that's my handwriting. That's the problems I had, but then the rest of them I got from the group here at Parkview, and they exclude certain types of A's. Like, look, so here, watch. I'm gonna go 1 squared and 2 squared, right? But then after I go 1 squared and 2 squared, what did I have to do last week? What did I do last week after I squared 1 and 2?
Oh, did you multiply it?
I did multiply by A, yeah. So somebody was asking me, hey, mister, do you always use 1 and 2? And I said, yeah, I mean, unless there's some mitigating circumstances, but, one of those circumstances where you might not use 1 and 2, it would be depending on A. Can anybody think of what types of numbers you have yet to see on A?
Big number.
Big number.
Okay, yeah, you're right, there have been, but then big numbers are not a big deal, just big numbers would make the graph bigger, but that would not keep me from using 1 and 2. What other types of more evil numbers that necessarily aren't fractions? Yeah, you haven't seen fractions. So what happens is, since I get some of the problems from the group that we have here, and like in the first semester when we took this first time around, on the test they wrote, they didn't put fractions there either. So yeah, I mean, unless there's fractions, I'm gonna use 1 and 2. When there are fractions, then you get into strategy and stuff, and what would make the most sense. You'd probably want to pick numbers that would cancel the denominator, because there's no denominator, there's no fraction. But I don't want to confuse you, so let's just keep it to this. There won't be fractions for A. Actually, there might not be any fractions at all on the test.
like fractions here. You should have a middle fractions.
Fractions not welcome.
Yeah.
1 squared times 1 is 1. 2 squared times 1 is 4. So what does this mean? I chose the first number.
It means because
That first number means what's going to happen to the left or the right of the vertex. Either one. It doesn't matter. You can go either way. So 1 left or right or 2 left or right. But now the result is where you're going to go up or down. So there's 2 ways you can think of it. You can think of it, hey, if I got positive, that means I'm going to go up. So 1 up and 4 up. Or you can think of it as, gee, since I already knew that the parabola was going up because A is positive, that means I also have to go up. So what I now know, starting at my vertex, if I go 1 to the right, I have to go 1 up. I could also go 1 to the left and 1 up, or you could just think of it as that you flipped it over the axis. If I go 2 to the left or the right, not from the last point I left off on, but from the vertex, so either 2 to the right or 2 to the left, where do I have to go next? 4 up. So 2 right, 4 up. Use your fingers for counting. 2 to the left, 4 up. We talked a little bit earlier about how when you're in vertex form, the small cost for being given the vertex for free is that you're not going to be given the y-intercept, but who cares? I mean, I'd rather have vertex if I have a choice. But here, I ended up finding the y-intercept. Where's my y-intercept? At 0, 4, yeah. I happened to stumble across it. No, we were just trying to graph, so now we graphed. Yes. What don't you get? The parabola, I just connect the dots.
Yeah, you get the 2 from the H, right?
I get the 2 from the H? Yeah, the axis of symmetry, I got the 2 from there.
And then?
The vertex is H comma K. So 2 comma 0 was where I put here where we changed direction. Okay. But then I want to know what happens. What happens if I go 1 away from the vertex? What happens if I go 2 away from the vertex? What happens if I go 3 away? Like, I want to know what would happen there, right? I want to be able to have at least 2 points on each side. So the first one I chose was 1. Let's see what happens 1 to the left or the right. You always have to square it because it's quadratic, and then multiply it times whatever A is. A was 1. What's 1 squared? Times 1 is 1. So since the positive 1, if I go 1 to the left or right, I have to go 1 up. So I started at the vertex, I went 1 to the right, and then I went 1 up. I put a point. I went, you could either think of it as you went 1 to the left and then 1 up, or you could think of it as once I put that point there, since this is 1 away from the axis, I can just put it 1 away on the axis on the other side. Okay, if I then want to know what's going to happen 2 points away, that's where I put this 2 up here from. 2 squared is? 2 squared is? 2 times 2 is 2? What's 2? 4. 4 times 1, because this is still times A, is 4 times 1. 4. So 4 up. So if I go 2 to the right, I have to go 1, 2, 3, 4 up. How far away is this from the axis? 2 units. Dos unidades. So then I just go 2 on the other side and I put a point. And then connect the dots with a U. Yes.
Why are we changing the sign for H? It's just like you have
Because in the formula, you have a negative in front of H. So what we went through, I don't know if you were in the potty or not, but like what we went through was that when you have a negative in front of an unknown, what you think you're seeing is actually the opposite sign. The reason why on this one you saw a -2 The minus came from the formula, therefore h was 2. On the before that, like for instance here with a plus 5, your eyes are seeing plus 5, but the reason why there's a plus 5 is because the formula already has an x minus, and then if h is also negative, what's minus minus? Plus. So like the easy way to remember it is just change the sign. Now you asked why is it, so I tried to explain why. Either you get it and dollars. Okay, so now the structure, we kind of revert back to what we saw last week, where we have to answer these questions. But because we're going to be given the vertex for free, it's going to go much faster. Let's first identify A, H, and K. Last week we were identifying A, B, and C. This is in vertex form. Let's identify A, H, and K. What's A here? Jocelyn, it's easier to understand. 2, what's H? -1, what's K? -6. So now I don't have to find my vertex. I already have it. Jocelyn, where's my vertex going to be at? -1, -6. Which means my axis of symmetry is going to be at x equals -1. Right, that was the same thing we did last week. I have to wait a little bit longer for the vertex. My domain, what's the domain going to be? Okay, all real numbers, also known as negative infinity and positive infinity. Good. The range we can answer already, but maybe to help you with range, you might want to answer the next two questions first. Is this going to open up or down? It's going to open up, down? Up. Why up?
Because
A is positive. And if it opens up, is your vertex going to be on the top or on the bottom? Yeah, meaning this would be a min. So because this is opening up, the arrows are going up forever. So on the range, on the right side, we have a positive infinity. The vertex is a minimum. So how low does this graph go? It goes as low as -6. Thank you. It's a bracket. -6 will be the lowest point. That's wrong. Now, you get saved a lot of times by the fact that you have multiple choice, but if a multiple choice were to have a parentheses and you were to pick it, yeah, it'd be wrong. For the y-intercept, unlike last week, you're not given the y-intercept for free. You have two options, and you should know both of them. One would be just to graph and see, kind of like on this last graph, if we happen to stumble across it. And here we did, we just stumbled across the fact that it's going to cross the y-axis at 0, 4. But let's say you have a question that's not asking you to graph. Who wants to graph if you're not being told to, right? So the same way that we found the vertex algebraically last week, where we had to actually use numbers to find the vertex, you can do the same thing for y-intercept here. If you're given something in vertex form and you need to find y-intercept, just plug in a 0 for x. That works with anything. It even works with lines. If you want to find where you're going to cross the y-axis, plug in a 0 for x. Let's just do this one mentally. I'm not going to write it down. Just do it mentally, and then once we graph, we'll see if the story checks out. Emma, what are you worried about? The 0 plus 1? You don't like mental? 0 plus, just use your fingers. 0 plus 1? It is 1. And then 1 squared is? Also 1. And then 1 times 2. You're starting to lose me already. And then finally the last one, then 2 minus 6 is? Yeah. So we already knew the y-intercept was going to be 0 comma something. And now due to Emma's mental math, we now know it's going to be at 0, -4. I just did it mentally.
Why?
Because I put in a 0 for x. Instead of writing it down on the paper, required listening, you have to use different senses, your ears being the main one. No, 0 plus 1 is 1, 1 squared is 1, 2 times 1 is 2, 2 minus 6 is -4. Do it on paper if you wish. There's no special trick or synthetic substitution or Rapunzel or anything like that that we can do with this. It's that you have to plug it in. If you're going to do it that way. Or, this is not as reliable. But if you have to graph anyways, you could try to see like, okay, look, my axis of symmetry is going to be at x is -1. My vertex is at -1, -6. Put a point there. Huh? Yeah, but now I have to come up with the points on the side, Jocelyn. So you decide how far away you want to go from the vertex left or right, but just understand that the further away you go, the bigger your graph is going to get. So especially since I don't have a fraction here for A, my approach would change if I had a fraction there, but since I don't have a fraction, I'm going to just choose 1 and 2. What's going to happen one space away? What's going to happen 2 spaces away? Now, once you start with that 1 and 2, you have to square them, because it's a parabola. Es un cuadrado. And then you have to multiply times A. So this times 2 and this times 2, because A was 2. 1 squared, or let's try to do it without Emma's help this time. 1 squared is 1 times 2 is. So if I go either 1 to the left or 1 to the right, I have to go 2 up. Positive 2 up. If you're not sure whether to go up or down, another thing you can look at is where the parabola goes. Wherever the parabola goes, the points have to go also. Parabola is going up. 2 squared is 4 times 2 is 8. So if I go 2 to the left or to the right, I also have to go 8 up. And now it's just counting. So 1 left or right, 2 up. Hey, look at that. I happen to stumble upon my y-intercept. And when you look at that, where did it end up being? At 0, -4. Then if I go 2 to the left or the right, I would have to go 8 above the vertex, which would put me at 1, 2 or -3, 2. Huh?
Okay, so you get to the -1 to the y-intercept, right?
Mm-hmm.
And -6.
1, -6.
-1, -6.
Yeah, for the vertex. -1, -6 was down there for the vertex.
Okay, -1, -6.
And I just draw my little parabola. You just flip them over the axis of symmetry. This is 1 space away, so you flip it around and do 1 space away on the other side. Parabolas are symmetrical. You're using it como un reflejo, like a mirror. This is 2 spaces away, so I go 2 spaces away on the other side and put a point. Here. What is the distance from this point to the axis of a symmetry? It's 2 spaces away. So if you put a point then 2 spaces away on the other side, there's a point. This is not new. We did this last week. Really, the only thing new today is that you're being given the vertex for free, which is something that you should be fond of. Soha likes it. Whoa. See, this is what I hate about math, is that now I'm starting to understand things, and you just completely went and changed everything.
I was trying to go on ahead and I looked it up.
Because you started off this lecture saying that vertex form is supposed to have a parentheses, and look at that, this one does not have a parentheses. How dare you, sir?
I can't, I don't get it.
Okay, watch this. Watch this, ready? Okay, fine. So then let's do it your way. If you don't have a parentheses, then what form do you believe that this is in?
Standard. I don't know.
Okay, standard. So in the standard, we can identify A, B, and C, right? Okay, so that's like it was last week. We're building on something familiar. And if this wasn't standard, we're not writing a pen. Yeah. Well, hold on. Well, if this isn't standard, what's A? 1. Okay, what's B? No. No. Remember, this is ax squared plus bx plus c. Since there is no x term, b would be 0. And then what would c be? Negative 3. Well, here's the big reveal. Anytime that b is 0, okay, can we all agree that b is 0? Anytime that b is 0, you have the option, which we like because we prefer to have a vertex, of switching out the b and the c for an h and a k. Because when there's no parentheses, as long as there's no b term, you can think of it as still being in vertex form, but because there's no parentheses, there's no h. If there's no b, there's no h. Okay. What's the benefit of thinking of it this way? Well, that I already have my vertex. And geez, you know what? Coincidentally, you know what else I already have? My y-intercept. These are one of the few exceptions where the vertex and the y-intercept are one and the same. This is going to change direction on the y-axis. The axis of symmetry will be at x equals 0. The domain is still negative infinity to positive infinity. The range is going to be where? If this parabola is going up and therefore it has a minimum, what's L range O going to be, O?
It's gonna be
Negative.
It is going to be something positive, all right? So let's start with that baby steps. Good. So it is going to be, since we're going up, something positive infinity. Thank you. Not 0, negative 3.
Bracket.
The bracket. Here, maybe this will help you. Look, on every single parabola, you know how I told you for domain, it's going to always be negative infinity, positive infinity? For every parabola, you're going to have one of two things. You're either going to have k to positive infinity, or you're going to have negative infinity to k. That's what every single one is going to be, but now it's too often. Instead of it being one thing every single time, it's going to be one of two things every single time. The range has to do with k. Range is up and down. K has to do with y. So all of your ranges are going to look like that. You have to put whatever k is, and then you also have to know which one it is. Here, maybe I can even help you out more. Watch. This is if the parabola is going up. This is if the parabola is going down. I don't know if that helps more.
Oh. Yeah, that makes sense. But the negative 3 is is y, and it's not x, but it's in the x spot.
Why is it in the x spot? Where do you see it in the x spot? This is not.
The negative 3 is
yeah. Range is not x and y. This is not the same thing as an ordered pair. That's an interval. It's just saying how low. It's just a different way of writing. How low and how high. This has nothing to do with x, comma y. Range is only y. Domain is only x's. It's just a way of saying a set of numbers. It's your high end, your low end. Yeah, because you guys see the comma and you think x and y, but that has nothing to do with x and y. It's just a different way of writing sets, a number set. It's just saying, hey, okay, range, cool. I already know range has to do with y. What's the lowest y I'm going to see? Negative 3. What's the highest y I'm going to see? Positive infinity. So now when we graph, axis of symmetry is at x equals 0. So I draw a vertical line right on top of the y-axis. Sarah did the same thing already. And my vertex is at 0, negative 3. But now, Jocelyn, I need to come up with the lateral points. How can a y-intercept be infinity?
Because,
The only thing, look, a
never mind.
parabola can change direction
Yeah.
wherever it wants to. It just happens to be that here, this parabola wants to change direction right on top of the y-axis. So I need to know what's going to happen on the sides of the parabola. Because a is not a fraction, there's nothing keeping me from just using a 1 and a 2. So square the 1, square the 2. You have to do that first. But then after that, what do you do? Multiply by a. So times 1 and times 1. This gives me 1. This gives me 4. Oh, as the cool kids say. So if I go 1 left or right, I go 1 up from the vertex. If I go 2 left or right, I go 4 up from the vertex. 2 away, parabola, parabola, hip hop hurry. Fax machine. Any questions there? Dario, no questions, good. All right. A, H, K. What's A here? -1, Emma G. H is -1, and then K is 6. So, ¿dónde está el vertexo? I'm just telling you this. It is -1, 6. Axis of symmetry is that x equals -1. Domain, negative infinity to positive infinity. J Bizzle. Where's my range of? If it helps you, this is going down, therefore, huh? So this is headed down. No, I already did domain for you. Just give me range. Remember, this parabola is headed down. A is negative.
6.
No, because now on the low end, it would be negative infinity. Actually, no, I'm sorry. Wait. Yeah, negative infinity. I had that right. Up until 6.
Isn't that the domain?
No, the domain's always going to be all real numbers. Domain means how far left, how far right. Every parabola goes forever left. So this goes as low as negative infinity, as high as 6. Y-intercept, I don't know yet. I could find it algebraically by having Emma do mental math, or I can just graph. So let's just graph so we can save some time. X is -1. Vertex at -1, 6. Jocelyn, I'd like to see what's going on left or right. So let's go 1 squared and 2 squared. See what's going to happen. 1 away and then 2 away. But before I can plot it, what do I have to do to that 1 squared and 2 squared? Multiply by? Yeah, A, which is -1. So times -1 times -1. This gives me -1. This gives me -4. You don't go up -4 now. That would mean you would go. Yeah, you don't go up -4. You go this. Okay, so 1 left, 1 right, 1 down, 1 left, 1 down, or 2 right, 4 down. Look at the cross. Connect the dots like in a coloring book. Do you ever used to use those coloring books where you would first connect the dots to like draw the picture and then you would color it in? That was fun. You know that they have those for adults too, but that's like the points are like super close, like or not super close, but I mean like there's like a lot of like 1,000 dots. Y-intercept here. Oh, very good. Thank you. So the y-intercept, where did that end up being? At 0.5. Good. Thank you. The y-intercept ended up being at 0.5. All right, let's do this. Let's skip now to the ones that have my handwriting on them again. Actually, no, take it back. Let's do this one here. Let's do the one that says number 4 first. At the very end, there's some that say convert. We're not doing any conversions. That happens at the beginning of the second semester if you're lucky enough to make it there. You know that wall spelled backwards as well?
Wow. You know why? What's that?
So A is -2, H is +1, K is 2. This will be the last one that we do of this type. We have to write all the stuff in. So 1, 2, axis of symmetry is at 1, domain is -infinity to +infinity. Jason, what's my range here? If this is going down, which means the vertex is a max.
-infinity. No. I mean 2.
The y-intercept, I don't know. I could find this algebraically by plugging in a 0 for x, but I'll just graph. I want to make Emma angry. Lives have been lost by making Emma angry. 1, 2. That's my vertex. Oh, jump to the left. Let's see what's going to happen. 1 to the right and 2 to the right, or left for that matter. We got to multiply each one by -2. So this gives me -2, this gives me -8. So you're not going to go up -8, you're just going to go down 8. 1 to the right, 2 down. 1 to the left, 2 down. 2 to the right, 8 down. That would put me at -6. I'm going to flip that. Good look. Jason, where did the y-intercept end up being? Oh, you before.
That's a bag. I didn't even know.
Y-intercept is at 0, 0.
Have fun, guys.
They will, they're in algebra. Any questions there? Okay, let's try to get 2 more done before we leave. All right, here we go. Here's another. Let's just graph these. This is in vertex form. What's A here? What's A? Sean, A? It is. What's H? -7. Change the sign. K is -8. So I can go draw my axis of symmetry over -7. And the vertex is going to be at -7. It's going to be right on top of that line, but at -8. This parabola is going to face up because A is positive, but let's see what happens at 1 squared and at 2 squared. You got to go times 3 each time. 1 squared is 1, times 3 is 3, 2 squared is 4, times 3 is 12. So if I'm going to go 1 space away, I got to go 3 up. So I'm going to go 2 spaces away from the vertex, I got to go 12 up. I'm going to have to borrow some toes to count. Emma, keep your shoes on. So 1 to the left or right, 3 up, 2, and then 12 would be 4 above. So there, flippity flippity, graphity graphity. How was your face? One more, just for Jerry. Let's do that one there. Oh no, what do we see again? For the second time today. There's no parentheses. So if there was no parentheses but there was a B, then you have to treat it like standard form. But notice how there's no B here. So we could still identify A, H, and K. What would A be? Still 1. Because there's no parentheses, h would be 0, and then k is -9. So this axis of symmetry will be right on top of the y-axis. This is one of the ones where we're going to have the y-intercept is going to be the same as the vertex. 0, -9 will be that vertex. And then one space away we square it, but we only got to multiply it times 1, which gives us 1. 2 spaces away we square it times 1, which is just 4. So once we go back down here, 1 to the right, 1 up, flip it over. 2 to the right, 4 up, flip it over, and then you celebrate. Any questions? Even if I don't see you tomorrow, I'm guessing I'll still see some classes. So if I go over anything else with them, I'll still post it online. And we can have a watch party at Emma's house.